All right, here we go with compound inequalities. This is the last section in this chapter. And so let's take a look at what this means and how we're moving from these Venn diagrams that we just did yesterday into this topic and how it relates to inequalities. All right, here we go. I can solve and graph compound inequalities. Okay, now you're like, well, that's a great learning target, but I really don't know what they mean. I see, though, that this term is in our vocabulary, so hold your horses. We'll get there in a second. Okay, we've spent this whole chapter thinking about solutions and graphing inequalities. So let's take a look at these two specifically. X is greater than 2. Here's 0, here's 2, open circle, shade to the right. Okay. And X is less than 6. This one would look like this. Here's 6, here's 0, open circle, shade to the left. There we go. Okay. What if I said, let's visualize this using a Venn diagram, okay? Where I said, okay, here's X is greater than 2. And this one is X is less than 6. This has an overlap region. Think about numbers that are bigger than 2 and at the same time smaller than 6. Oh, like 4 or 3 or 5, pi, 2.1, 5.99 or 5.5, okay? All kinds of things. In fact, there's an infinite number of values that can be placed in there. I'm not going to worry about it, but you get the idea. Out here, what are numbers that are bigger than 2 that aren't less than 6? Like 10 or 143 or the square root of 144. Okay, 99.9 repeating. Okay, there's all kinds of things up here. Likewise, there are numbers that are smaller than 6 that aren't bigger than 2. Okay, so think of, as you look at this number line here, what is where 2 is, and then beyond that, things like 0 or -7 or -15 2/3 or 1. Okay, or even 2 itself would actually be there because 2 is less than 6, but 2 isn't bigger than 2. There's no equal sign there. Okay, get the idea? Here we go. So what I want to do now is kind of put this back in the graph, but I want to talk specifically about this region where it's overlapped. When we look at what's overlapped, I'm actually talking about what happens when I put two inequalities together with the word and. So that means I have all of the values that are less than 2 and at the same time are greater than 6. Okay? That means if I look at a number line, okay, so think back how I started to graph this. Here was 6, open circle. I start shading to the left, okay? You're coming along here. 0's down here. Here's where 2 is. And at the same time, I want to talk about hold on. This is messed up. Messed up. I'm on this one here. Less than 6. This is where I'm at. Here's the 6, open circle, shading to the left. And at the same time, here's where X is 2, and I'm going greater than. And all of those numbers that were in that overlapped region is right there. Okay, if I want the ones that only satisfy both of them at the same time, you use the word and see if there's anything there. This is just exactly like this wedge of overlap in your Venn diagram. So when I write this and I want to combine these two inequalities together, you could just do it in words this way with the word and, You can also make this multi-staged compound inequality by writing it this way. X is greater than 2. Remember how I've told you I can't stand reading things when the variable's on the right? Well, here's a good example. If I switch this around this way, this says the same thing. X is greater than 2 is the same as 2 is less than X. Okay? And if I bring this on in with the existing X is less than 6, you get this 2 is less than X, which is less than 6. Compound inequality. Notice the X is in the middle. All your solutions are in the middle. And this is what it looks like. Okay? It's this overlapped region. Now, where I was getting a little ahead of myself and messed up is where I had things switched around. Okay, now, what if I had X is less than 2 instead of greater than 2? So here's 0, here's 2. I'd put an open circle and I'd shade to the left. X is greater than 6. So here's 0, here's 6, open circle, shade to the right. Okay, if you start thinking of these two inequalities, here's what's happening. Okay, I have numbers greater than 6. I have numbers like 7, 8, 9, 10. Are any of those less than 2? Okay, what are numbers that are less than 2? Like 1, 0, -1, -2, -3. Are any of those greater than 6? 0, -1, and so on. Will there ever be anything in this overlapped region? Because if I somehow were to lay these two on the same number line, watch what is going to happen here. And I'm going to need to get my eraser out because I know I had a oops on this next page. So hold on a second. If I tried to overlap these two, this gets a little wonky because on the same number line, if I have 6 here and I'm going greater than, okay, and then here's my 2, and I'm going less than, there is no overlap. There is absolutely no number that can be both at the same time because there's no overlapped region. So when you have a situation like this, where you put the two graphs together, there's absolutely nothing in common. You've got one end going to positive infinity, one end going to negative infinity. We can't use the conjunction word and, we have to use the word or. I'm going up this way or down this way. Can't include both at the same time. The one before this, where you had an overlapped region, then you can say and, because you're talking like the peanut butter in the sandwich, okay? This is the filling in the middle that satisfies both. So today, what we're talking about, and let's get that definition up here now. Compound inequalities are two inequalities combined together, and they'll either be combined with the word and, that's where you get an overlapped region, or the word or, and that's where you have these two tails going off in opposite directions. Okay? That's what a compound inequality is. The two words that kind of illustrate this are these ones. The word intersection is when you have and. That's this. I have this, and there is an overlapped region, and there's a section that gets cut from both of them and satisfies both at the same time. That's why I like to use that visual of the Venn diagram so you see that. Or when you have a graph and you have this graph and they share some solutions, that is called the intersection. And that's when you'll see the word and joining the two together, or we'll write it with the variable in the middle, and you'll have your two symbols, and you'll have numbers down here like, say, 5 and 13 or something like that. A union is where you will see the word or. This is when you're combining two inequalities, and either you're going to have a solution up here or you're going to have a solution down here. There's not an overlapped region, but we're going to say if it satisfies either one of those two, knowing that there's nothing that crosses both of them. That's the union one. So how does this work? What does this look like? What on earth is she talking about? All right, let's say you're some sort of research scientist, you're an ace in chemistry, and you're coming up with some fancy new shampoo, and you have to make sure that the pH level is safe, and so you know you have this tolerance level that it has to be between 6 and 0.1, 6 and 5/10 inclusive. The word inclusive there means that it can be exactly 6.0, it can be exactly 6.5. Write a compound inequality to show the pH levels of this shampoo and then graph it. All right, so I know between 6.0 and 6.5, and I can include those. So you put your variable in the middle, knowing that it's going to be exactly between these two. This is the low end, this is the high end, and I'm using less than or equals to because it's an inclusive. What does this look like as a graph? Zero's down here somewhere. Here's 6. Here's 6 and 5/10. Both of these are solid dots. And then it's only these values in between the two. There's no shading of arrows. I'm not extending beyond to the left or the right, just the part in the middle. Okay? It's as simple as that. Now, we take it one step beyond, okay, because it would be awfully easy just to have them there and you just graph them. How do you solve if in the middle of this inequality you have more than just the variable? Well, do you remember when we were solving either equations or inequalities, I said, I like to put a line underneath either the equal sign or the inequality symbol to make sure that you are performing operations on both sides at the same time. When you have two of them, put two little bars under here. Our goal is always to get the variable by itself. So to undo that adding of 1, I'm going to do the inverse and subtract 1 because these are opposites and they cancel each other out and go to 0, and I'm left with just x. However, if I subtract 1 in this part of the inequality, you need to do it in all of the sections to keep things in the same relationship or preserve that. This now becomes -6. This becomes +1. When I am simply subtracting or adding, I don't have to worry about inverting or flipping an inequality sign. So I'm left now with this. I can graph that, okay? -6 would be down here. 0 would be here somewhere. Here's 1. Both of these less than symbols or symbols imply an open circle. Now, x has to be bigger than the -6, but at the same time smaller than 1. So it's going to be all of the real numbers between -6 and 1. And there you go. That's what it looks like. How about this one? Ooh, okay, a little more complicated. That's okay. It's okay. I'm going to put a bar under each of these inequality symbols because whatever I do in the middle, I have to do the same operation on either side. I'm going to counterattack that subtracting of 1 with adding 1. You have to be fair and do the same thing over there and over there. This becomes 9. This simplifies to now just 3x. This is 12. Okay, no changing of any signs, no flipping, no nothing. Okay, keep continuing to get your variable isolated or have a coefficient of 1. So I have to divide by 3. That means you have to divide this by 3, and you have to divide this by 3. 3 divided by 3 is 1. 1 times x is x. That's exactly what I wanted. 9 divided by 3 is 3. 12 divided by 3 is 4. Oh, okie dokie. Here we go. So this one is going to be pretty tiny. Here's 0. Here's 3. Here's 4. Careful with your circles now, or your dots. This will be an open circle at 3. This symbol implies a solid circle at 4. And just shade in between the two, because my solutions have to be greater than 3, but less than or equal to 4 at the same time. This is an AND inequality, compound inequality. Okay, how about if I give you the graph? Oops. Or let's say this. This is this compound inequality, or. Okay, so first because it says or, you get it in two separate inequalities here. And let's go ahead and solve this one. I want to get t isolated, so I am going to subtract 8 from each side of just this inequality here. And I get t is greater than or equal to -1. Okay, come over here and solve this one. Counteract that 8. That goes to 0, and I have t is less than -6. All right, so let's think about what this looks like, and that's why these graphs are here. Okay, t is greater than or equal to -1. That's this one right here. Okay, if you think that this is 0, here's -1, solid dot, I'm shading to the right. T less than -6 means I'm going to have an open circle at -6, like here, shade to the left. There's no overlap region on these two, okay? So here's what happens when you combine these together, okay? Here's 0, here's -1, here's -6. Put them on the same number line. Greater than or equal to -1 looks like this. Less than or equal to -6 looks like this. You basically have two tails going in opposite directions. There's no overlap at all, so you have this open space in the middle, and your solutions are either in this shaded region or in this shaded region. So when you see the or, that's implying you're going to get this situation, and an and is going to have some kind of overlap. All right, let's look at this one. Okay, and in fact, what I'm going to do is just cover this up because I think that it's kind of annoying to have the graph there. I think it's distracting. So let's say I give you this compound inequality. 4x is less than or equal to 20, or 3x is greater than 21. Solve each one first. So you get the variable by itself so you know what you're dealing with. This says x is less than or equal to 5. Or solve this one. 3x greater than 21. You're going to isolate your variable and you get x is greater than 7. Okay, draw one number line and let's see what this looks like. Here's 5. Here's 7. Less than or equal to 5. Solid dot. I'm shading to the left. Fill in the arrowhead. Or x is greater than 7. Open circle, shade to the right. As you can see, they encompass a lot of the number line, but there is that gap in between the 5 and the 7. So either your solutions lie in this part of the shaded region or over here on this part of the shaded region. You have nothing that satisfies both of them at the same time, and that's why you have to use the word or. Okay? Sweet. What if I just give you the picture? Can you come up with what this compound inequality would look like? Well, this part of it looks like x has to be less than or equal to -8. This part looks like x has to be greater than 0. And since there's no overlapped region, you just combine them with the word or. Cool. How about this one? That's weird that they put the 5 there. Just put it down here the way it's intended. Okay, this I just have kind of like two endpoints and shading in the middle. That tells me that this is an and situation, okay? And I am at -2, I have values that are greater than -2, but at the same time, I have my values of x that have to be less than 5. So if I want to put these together, I mean, in theory, you could leave it like this because we leave the ors separated. We have to leave the or ones separated. But you can combine this into one statement where your x value is in the middle because that's where your solutions are. And you can use these two. You have to make sure your signs are going the same direction. That's why I have to turn this guy around and put the -2 here and put the x here, because then I can just go -2, 5. So you say -2 is less than x, which is also less than 5. And that implies the chunk in the middle. Okay? Let's give these a whirl. You haven't done something like this before, so I'm excited to see how you come up with these. So in your textbook, page 206, problems 16 through 26 all, give yourself some room, those of you that like to think you're only going to use one line per problem, and write in a microscopic kind of font. Hey, I'm old. I need my cheaters to see things. So don't be afraid to take some room on each of these problems, all right? There's only 11 of them. You'll be fine. Good luck. Show your work, and may the force be with you.